Question 16, 17, and 18 all have to do with properties of exponents. So question number 16 is 5 to the power of negative 3x equals 1. So at this point, for the time being, we're just going to think about this equation, and this whole side, left-hand side, has to equal 1. So if we think about powers of 5 that have to equal to 1, that's kind of a property of exponents that hopefully we recall from Algebra 2, but the exponent that makes that true is the 0th power. So 5 to the 0th power equals 1. Actually, anything to the 0th power equals 1. So we want this quantity up here set equal to 0, which we can set up algebraically. We can just say that if that thing equals 0, that'll make that equation true. So solving for x, we have a variety of ways to do that, but x is going to be equal to 0 for question number 16, property of exponents. 17, also a property of exponents. A little bit trickier because we have to think about the bases involved here. So if you take a look at both sides of this equation, this and that number actually have the same base. When you exponentiate, they're the same base. You might not notice this right away, but 216 is actually a power of 6, and 16 is actually a power of 6. 216 is 6 to the 3rd power, and 1/6 is actually 6 to the negative 1 power. So when you're working with these exponential equations, sometimes it's handy to get both sides to the same base. So if we do that, this is really 6 cubed. And this part in the parentheses, 1/6, is the same as 6 to the power of negative 1. So we get this relationship. Well, the nice thing about this is when you have an equation with the same base on both sides, you can set up an equality. Let me clean this up a little bit more with this property. A exponent to an exponent, we use multiplication to combine those exponents. So this whole left-hand side is really 6 to the power of, if I multiply that negative 1 times that quantity, I get negative 1. Negative 1 times 1 is negative 1. Negative 1 times negative 3r gives me positive 3r. So that's the whole exponent to the left-hand side, and then is 6 to the 3rd on the right-hand side. Well, for this equation to be true, this is saying 6 to some power equals 6 to some other power. In order for that to be equal, these two powers need to be equal. So we can actually set up a new relationship, a new equation, which is setting those powers equal to each other. And now it's a linear equation solving for r. So add 1 to both sides and divide by 3. And there is our exact improper fraction answer for question number 17. If you have it in decimal form, 1.3 repeating, but we prefer improper fractions. The last question, with dealing kind of with properties of exponents, and actually number 18, it's handy to be able to use logarithms, but if you aren't as familiar with logarithms, I'm going to kind of show you a way to cheat on this one. So logarithms is kind of the nicest way to solve this algebraically, but I'm going to talk about logarithms in the next video. So this one thing you can do is, our variable is n. We're trying to get n by itself. So we can actually do a little bit of algebra work before we worry about it being in the exponent, meaning we can take this side and write it 7 to 3n, and we can divide both sides by negative 10. So over here we get 21 tenths. Negative and a negative will make that a positive, and for what we're going to use our purposes, we can even think about this equation right here. We divide that by 10. We get this relationship, 7 to the power of 3 times n equals 2.1. So let's think about this relationship right here. I mean, if we think about powers of 7 and we want to make it equal to 2.1, if we think about 7 to the 1st power, that's going to be 7. So that's over that mark. That's too high. 7 to the 0th power, we talked about in a previous problem, is going to be the number 1. So whatever this exponent is, it's going to be some number between 0 and 1, and it's not going to be a nice number to get this, decimal. So properties of logarithms is what we're going to talk about next video. So I'm going to show you a way to do this without properties of logarithms and using your graphing calculator to kind of help you think about this. So we can think about this equation, and we can think about two functions. This green, call that the left-hand side function, and this function, a constant, 2.1, just a horizontal line. So, if I wanted to, I can use my graphing calculator, and I can graph this as y1, and I can graph this thing as y2, meaning y equals that thing for one function, and y2 equals that thing for another function. Well, this thing right here is an exponential function. Hopefully you knew that, so it's going to be going up with the properties of the coefficients like that. So you're going to get, let me draw this color-coded, you're going to get some function. This is just a generic quadrant 1. Something's going on. Let's go through at 7, so it's going to be some function like that. This is the function, y equals 7 to the power of 3n. Okay? Just a generic kind of idea of what that does. This is a constant function. Y equals 2.1 is going to be a horizontal line somewhere like that. Y equals 2.1. So what we're trying to figure out with this equation is, where is this side equal to that side? Graphically, we want to know that point right there. Now the directions on this said round to, I think, 4 decimal places. So with those directions, we can actually use our calculator and get an approximation. If we wanted an exact answer, the calculator will not do that for us. We would need to use this method with using properties of logs for an exact answer. But hopefully you know how to use your calculator and find the intersection of these two graphs using some of the second calculate function and find the intersect of those two lines. So using the calculator, using the technology, we get 0.1271. And we should throw an approximate symbol on there since that is an approximation. And like I said, the direction said round to 4 decimal places, so that's a good enough way to get this answer. Again, there is a more algebraic process and exact process using logarithms, but that's question 6.